Okay, so a lot to cover. Thanks for having me. First of all, I wasn't meant to be speaking here. I just submitted. I told the Oak Cliff team about what I was working on, and they were like, "Why don't you come to speak about it?" And here I am. So I just want to introduce you to my favorite CLI to start off this discussion, and it's called Rupa/Z. Anyone here heard about it? One person? Okay, your mind is going to be blown. So this is my current work folder. It's can everyone see this size? So I'm in my work folder right now, and Rupa/Z is just one command, and I type in whatever folder I want to jump to. So for example, if I want to jump to my Netlify folder, it jumps there, and I can specify whatever I used to be working on as well, and it just jumps, and it can match on a partial string basis. It just jumps to the most recent project I work on. So for example, if I go on to work and I make an Oak Cliff conf folder, I'm now in my Oak Cliff conf folder, right? I can jump back to my React folder. I can jump to my Netlify folder. I can jump back to Oak Cliff just by typing that. That's Rupa/Z. It's a CLI with only one command and one behavior, but it's so adaptive it learns me instead of me learning it. And that's what I want to motivate this whole discussion with. Okay, you also see, and this behavior is called frecency. It's a mixture of frequency and recency. So there's a mathematical algorithm to trade off that. Yeah, right. There's actually a formal spec, and it's been implemented in Slack. So those of you who use Slack, let's say I'm referring to this person a lot. They'll actually promote it up front. The more you use the more you use the interface, the more it learns you, and the more it adapts to what you do. And so that's the title of my talk. It's Adaptive and Intent-Based CLI State Machines. That's a mouthful, and I'm going to be honest, it's actually should be called ridiculously over-engineered command line apps. So everything here this is more of a science fair project that could be real someday. All right, I just want to give that phrasing. I'm going to give this in two talks. I'm going to talk a little bit about where I work, Netlify, just to give you the context for what we ran into, and then we'll talk about the problems and some solutions. And also a disclaimer about this part. This is mostly my colleagues' work. I only joined Netlify in August of last year, so definitely a lot of this was done by smarter people than me. Netlify started life as BitBalloon. Basically, you drag and drop. You drag a whole bunch of static files, drop it here, and then it's a static site host. Basically, GeoCities or NeoCities. I don't really know the difference. We then saw a lot of static site generators, so we wanted to promote that. So we created staticgen.com, and we started tracking numbers for the rise in static site generators. Shannon from the Gatsby team is here representing one of the now VC-funded static site generators. So then we noticed this trend, and we started writing about it. And this is essentially the founding thesis of Netlify, which is why static site generators are the next big thing, and why static site hosting is here to stay. So that brings us up to pretty much today. Netlify is your a static site host with and helps you build and deploy your static sites. We have a web UI, and it kind of looks like this. You can pick your sites, you can pick your look at your deploy logs, and you can change your deploy settings. So obviously, many people will use the web UI, but there starts to be a natural need for the CLI versions of all this stuff. So we went through a few iterations, pretty similar to a few of the journeys that I've heard here today. We started with a hand-rolled Node CLI. Then we thought, hey, our backend's in Go, we should write Go on the front end. So we tried Cobra, and then we realized that all our users only know JavaScript anyway, so we went back to Oak Cliff. We also hired Keiko from the Heroku team, so that was a major factor in our decision. So here's what the Netlify CLI looked more or less last year. Bunch of commands. We love the man pages. We definitely, I feel like adopting Oak Cliff as the base for our CLI was the right choice. Then we also started promoting this concept of the Jamstacks. So your static site is just a static assets, but what if you want to add extra dynamic behavior? We encourage people to use JavaScript to interact with APIs, and that's the J, A, and M of Jamstack. To enable that, we started launching Netlify Functions, which is essentially a nice wrapper over AWS Lambda to provide serverless functionality to static sites. Now, that's in production. What about local testing? So that's the problem that we started to solve: local emulation. And if we've had a previous iteration of this, but then eventually we started landing on this problem. So the other thing that also started rising was dev servers. So for example, Create React App, Gatsby, Nux, Next, all these other static site generators. They'll spin up a local dev server so you can preview your changes in the browser and hot reload and do all that fancy modern JS stuff. The problem with these dev servers is that they're harder to manipulate. So for example, if you wanted to locally emulate functions, you had to spin up your function server, configure the dev server to accept that, and then output a nice unified experience for your local browser for testing. And this is just an example of how much configuration that needs. This is the old project, and I'm just scrolling through the README. And this is everything you have to read to be able to configure local testing of your serverless functions. And we had examples of how to configure Create React App, Gatsby, React Static, Nux, Vue, Angular, and every single little project has their own little twist on how to do things. So it's a lot to read and accept and maintain. And that was the status quo before what we launched this year, which was Netlify Dev. And that was a reimagining of this approach, and also a doubling down in our commitment to our CLI and our commitment to Oak Cliff. And the goal is to solve the deploy and pray problem. Like for the stuff that you can't locally emulate, you have to deploy and hope that it works. And if not, just figure out like what's going on and hotfix it. And so the general idea is that you relegate the dev server to one input. You have your local Netlify dev server that's running, and that's listening to that dev server. You also add in your serverless functions, your redirects, and environment variables injected from your production environment, and combine, basically take the entire production platform onto your local desktop so that you're previewing it in the browser. You can then also share that live through a live tunnel with your coworkers and designers and PMs and stuff. So that's a lot of functionality, right? That new functionality that we're sticking into the CLI. And so we started developing new commands, new configurations for those commands, and more prompting and more CLI output. And all of this was supposed to be done in private because this is one of the big product launches. And so all of this would not be possible without Oak Cliff plugins, and that's one of the premier features of Oak Cliff. I can't say enough good things about how this made private development of new functionality possible for us. And then we launched it 51 days ago. It's our most successful launch of a product to date. And I just want to give a round of applause to the Oak Cliff team for making this possible. Thank you. And so now we're going to get technical, and that was all like an introductory context into what we face and what I face as I took over this project. And so some of the requirements that we did that we ran into facing this, which is like reading config, checking state, checking for folder existence, respecting flag overrides of every single one of those, and prompting for what's missing. Everyone here, if you're working on CLI, has run into some version of this, and you enforce it, implement it inconsistently at best. And I was trying to figure out like some more unified philosophy of CLIs, and that's how I discovered Jeff's 12-factor apps. I actually expected everyone here to know about it, and I realized some of you may not have read it. Definitely go check it out as the summation of his years of experience in writing CLIs. And also notice that Oak Cliff helps some of these factors more than others. It helps generate help docs and version, but it has no real opinion on, for example, being fancy or or how you prompt for things. And so definitely, like, Oak Cliff is a step towards 12-factor apps, but there's a lot that's still left for us to implement. I also started, because this is how I learn things, I also started collecting all these libraries and useful tools in a cheat sheet. And I think there should be a community well for that. Jeff thinks this should live in the Oak Cliff repo, but then I also, show alternative to Eclipse. But you know, reading from the file system, prompting, argument parsing, command execution. I just want you know, a single source of reference for CLI builders to be able to discover new functionality that they might want to add on to their repo. So definitely come contribute if you want. That's the CLI cheat sheet. So that brings us to part 2. So the part 1 was just like things as they are today. Part 2 is sort of the mad science part of it. And this is my sort of bold proposal for the 13th factor of CLIs. So a little bit about myself. So that was like the work of others. This is about me. I work on developer experience at Netlify. I help to moderate the r/React subreddit. So if you're hiring or looking for a job, if you're hiring React developers, there's 115,000 of us there. And I also sang the Babel theme song. If you go onto Babel and look for the theme song, you can hear my awful singing, which is why I work on CLIs today. And I'm also pretty interested in human-computer interaction. I actually did a course recently on that, and I had to cut out some slides. But essentially, one of the principles in human-computer interaction is that your interfaces should be tolerant and adaptive. Like they should, the more they can learn you, the less the user has to learn. The less you have to document, the less, and the more adaptive it can be to errors. The more tolerant it can be to errors. And so that's where I come from. I come from a front-end background. And I'm a newbie to this CLI development, so I feel like a relative imposter here, but I'm just showing what I think when I come into this world of CLI development. And so here, I looked around. It's hard to get a good definition of adaptive interfaces because a lot of them confuse adaptive with responsive, which just means like you resize things as you change the window size. But here, interfaces that adapt on the fly to the current user and collect data over time to inform that experience. I think it's a really good definition. And if you want a reference example, think about Rupa Z, right? When I type Z and I type the folder name, I don't have to spell it right. I don't spell all of it, but it just remembers and it just works as expected. And so the missing 13 factor is state, as far as I'm concerned. Like it's really hard to do, and the more state the CLI can accumulate about you, the more adaptive it can be. So there are two problems with that. Problem 1, state is hard. So let's play a little game. Who's written something like this when you want to store code? Yeah, store data. The problem is you probably have not written something like this. You've probably written something more like this because you don't want to override your data every single time. So you want to assign keys in your objects, and you probably even this is wrong. Can anyone tell? I'm not going to play this game. This is the reason. The reason this is wrong is because files can be corrupted. So you want to do atomic file writing. So that's why Sindresaurus, the Lord and Savior of JavaScript, is implemented write file atomic, which is one of these utility packages inside your node modules that you probably don't know about. So that's file storage. What about file reading files? Anyone want to tell me which of these is going to resolve to the wrong game? I set up this example. I think I have time for this. So let's play this small little game of. All right. So temp.js. Okay. Here we go. So between. I hope people can see this. Between these two, path.join and path.resolve, do they resolve to the same folder? No? I think they do. Oh, hang on. Did I? I think it's public. Sorry. Yep, they do. So path.join and path.resolve, with their names, they resolve to the same folder in my setup, which may be different from yours. Again, obviously, I think some of you are thinking about like whether you're working within a CLI and it's used in somewhere else or not. Process.cwd, that's a little bit more useful. All right, they should produce the same thing. Let me just reduce the font size again so that people can see. Yep, they resolve to the same thing. So path.join, path.resolve, pretty much the same thing. How about this? path.join, path.resolve, but then you're adding additional folders in between because you're dynamically computing them or whatever. Do they resolve to the same thing? No, the second one just resolved to slash. So like there's a lot of little tricky things, and I'm sure you implement, like, you know, as your team grows, the more inconsistently you're going to implement all of these path resolution algorithms, right? And so that's the tricky bit to even getting this string right. And so these are all the hurdles that we run into when we talk about trying to persist state, and that's why by default a lot of CLIs are stateless. And then we talk about Windows compatibility, right? Once you launch, obviously you always forget about Windows, and obviously the XDG spec, the 12-factor in the 12-factor CLI spec. All these things have been worked out. It's just that they're not the default, right? And that's just not how we do things in Node. And so we have to learn about what the right libraries are so that we are abstracted away from managing this stuff. So basically, don't roll your own storage. Use Sindresaurus's conf library. John Slinkert's data store is also really good. Cosmic config. Some of you here already use it. This is a different thing. This is not for mutable storage. This is more for reading user supplied configuration, and it traverses up the files just like Jest and Yarn and I don't know what else in the Node ecosystem. But these are all, and here's an example of the conf CLI, right? It's really simple. You require it, you declare a new version of it, and then you just set keys, just like you're in browser local storage. You set, you get, and delete. Simple. But there's typically different sources of storage inside of your CLIs. And so I try to think about what a full model of CLI state really looks like. So you can have flags, you can have project state, you can have project file system. Let's say you have like a kind of like a convention over configuration type of system. So you have different folders and you're supposed to detect that. You can have machine state and you can have remote settings as well. And that's why I started working on a unified solution to manage all of this thing, and it's called and I call it CLI state because I couldn't think of a better name. And the rough API. I don't have time. I don't have time to show the rough API, but basically it helps you resolve the differences between project state and machine state. So I'm just going to skip that for lack of time, but but you can come to me after for a demo. We also have to think about caching offline some things because ideally CLIs can run offline, and so that's a useful point of research which I have not implemented as well. Sorry, I'm not in the best of health right now. Problem 2, CLIs as intolerant procedure calls. And this is something I see a lot, especially, and it affects me a lot. So here's an example of something my director of marketing slacked to me yesterday. So starting Netlify dev and then running into some configuration which was not fulfilled, and then ending, and then not really giving some instruction on what to do, but it's kind of cryptic. He didn't understand it, so he just had to run it again. This is from our Hacker News launch, so relatively technical crowd. Again, same story, different path to getting it, but same story, running into some configuration, some setting that wasn't fulfilled, and then stopping, because that's the default, right? And then I patched it with some helpful messages. But you can only get so far with just like trying to be helpful all the time. You have to basically anticipate everything the user can screw up, and I do not have that much time. Context is hard. So here's a nice joke. What do we want? Natural language processing. When do we want it? When do we want what? And that's the statelessness of CLIs, right? Like I just asked you to do this, and then you stopped, and then you're like, all right, I'm gonna add some extra querying, and then they'll be like, what did you just ask me? I don't remember. And that's not the way we interact with everyone else, but it's the standard for interacting with CLIs. It's very frustrating. So this general category of problem is handling incomplete state. right? How do you resolve things? Oh, okay, sorry. So the very worst is silent exit. When you run into something, you don't have something you require, and you just exit without telling anyone. And that actually happens. But the default is to throw an error, right? Because like undefined is not a function, right? Whatever. Better if you wrap it and try to get an error message out there, and that's another one of the 12-factor CLI apps. I feel like I'm just like reading out your piece to you, but it's awesome. Please go read it. Even a good one would be to prompt for a fix, right? Like, hey, you didn't supply this flag to me. I need it for this operation. Can you please and then prompt for it because it's missing, and then tell them in future you can pass the flag so that they don't have to go read the docs. So that's adaptive prompting. I'm just going to guide through a pseudocode example of how you've done it because we have all done this. So here's an example of a command, and I'm writing some business function, and the state.name is underspecified, so it just throws. And that's bad, but people can figure out that name is missing, so I should supply the name. So if you're lazy, you write an if wrapper around it. So this silences the error. It's even worse. Definitely don't do this. If you're good, you write this dot error. You write some logging and tell people, and you use chalk because you're a fancy developer. And you tell them what's missing and what they should do next. If you've read the 12-factor CLI essay, you actually provide an error code, error title, description, and how to fix an error URL. So there's all these little nuances to developer experience. I'm going to keep going. So then you can prompt, right? If the state is missing, I run the business. If the state is missing, I can prompt for what the missing piece of information. If that information is supplied to me, I can run the business logic again, note the duplication between the success state and the caught state, or else I can just give the error. We have all done this, right? More or less. So the key realization here is we're writing CLIs like we wrote jQuery. Not terrible, right? People got a lot of things done, but it's mixing a lot of business logic with like case handling, duplicating stuff, and this is in one command. Let's talk about two commands. It's not a strong point of Oak Cliff. So I have a login command, and it goes to login.js, and it executes login.js. I have a deploy command. It requires a login state, but it just goes to deploy.js, and I write all that error handling inside of deploy.js. What I really should do is have, ooh, look at that, it's so fancy. If my user runs deploy without being logged in, it should log in for me, go to login.js. Once it's done, then continue resolving to deploy.js. Yeah? Makes sense. Not the default of Oak Cliff. Oak Cliff says, no, this is a bad idea. You don't run a command from another command. So all right, what do you do? Have a utils folder, share logic, reuse logic, put a whole bunch of things here. This is fine until you have, 90 commands? Yeah. So not really super scalable. And the key realization for me here is that commands are not intents. As a user, I have an intent to do something. The CLI should be smart enough to help me figure it out and work with me. And right now, all we have is command interpreters. We don't have intent interpreters. So the solution is to use a state machine because I come from the React ecosystem. That's all the rage right now. I'm going to show you. Show you what the state machine is here. So it's a visualizer of all the possible states in your CLI at a high level. You don't have to model every state, but let's say you start in the idle state. You create an action. It helps to pass you through the different states you've explicitly modeled with explicit actions, and you can start to retry things, right? You can start to resolve things, and then sequentially pass through individual pieces of state, all explicitly modeled and statically analyzable and can be validated and visualized, right? That's like, I'm sure if I asked you to draw on a whiteboard what your CLI logic flow is, you couldn't because it's just intermingled everywhere. I don't mean this to be criticism at all. Like this is true for me. So that's what I'm running into. And so ideally, if I try to deploy and I can't, and I'm not logged in, I go reset to the nearest state. I search all the available states. I look for any possible path that leads me to the path I want. I log in, and then I finally go to the deployed state. I can even make arrays of that and just say, I have multiple dependencies on all of these states. All of them have their own resolvers, and I will not be repeating any of these logic. I just declare it once. And if I have a state machine, that can be dynamically resolved for me as and when each of these dependencies are needed. And then I can just execute my final function. And you can also do a shortest path algorithm if there are multiple ways to get to the same paths. This is more theoretical. I don't expect most CLIs to have this complexity. We happen to have that in Netlify Dev. But if you have multiple ways to get there, you can use the shortest path algorithm to do that. That's built into Xstate, which is the library underlying this entire thing. And that's the get shortest path algorithm. All of you have done it in your interview studies and never used it again. So this is the second solution I'm presenting today, CLI state machine. Again, not a lot of time to to do a live demo, unfortunately. But essentially, you declaratively define state. You have a name for that state, which, by the way, can also become a flag. You can have a getter for the value, and that can be reading a file, reading a variable, prompting, whatever. And then you assert on that variable to say whether this is true or not. And you can define actions that depend on those states. So actions take you from a before state to an after state. And to get you between there, you can execute arbitrary logic. And so that this can be more prompting. This can be a login action. This can be a deploy, what have you. You don't have to have a finite end state if you want. You can just have a before state. And that just declares all your dependencies, all your requirements before that must be fulfilled before this action can be executed. And so to run the state machine, you initialize it. For the API that I have designed, it's just an array of all the possible actions, so they can parse through all of it. And to process the state machine, you pass in your intent, which, for example, I want to deploy. It runs through all the possible states, figures out, all right, these states are valid. I don't have this possible state, so I'm going to run the shortest path algorithm, whatever. Or if the dependent state of deploy action is valid, I'm just going to run that immediately. So that's a very componentized model. More to do. So I have helper functions for file and folder existence as well as prompting, so that you don't have to do all this. Like even this is kind of wordy and verbose. Like imagine if you could do it in one command. So I have a bunch of helper functions that I'm working on, flags for these things, as well as visualizing, just like printing an output and pushing it to the Xstate visualizer, so you can visualize the state chart of your CLI. And the overall principle is to componentize your business logic and make it declarative. So you only write imperative code inside of the execute lifecycle method, whatever you call it. And then you have components, and you just kind of Lego them together in a declarative fashion with using this sort of grammar of states and actions. So let's bring together the two ideas, right? We can initialize the overall CLI. We can pull the CLI state. We can initialize the state machine, pull all the possible actions, and we pass the actions and the the CLI state that can be modified inside any one of these actions into this processing of the state machine. And that's the overall idea, is to have this framework. That's the intelligence layer behind of Oak to make everything else declarative, just like Oak did for command parsing and so on and so forth. And so yeah, that's the overall pitch. We desperately do need CLI engineers to help build this and other things out. So netlify.com/careers, that's exactly why I'm here, although I'm sure all of you have awesome jobs building CLIs already. And then this thing is more of an open source proof of concept. So my GitHub /CLI-state or CLI-state-machine. So 2 libraries, all introduced in 25 minutes. And I'm done. Thank you very much. So many questions.
Your cheat sheet.
Huh?
What was the URL to your cheat sheet?
That's the takeaway. Swix-CLI-cheat sheet.
Okay, thanks.
Yeah, but I find this useful because I'm just going through other people's CLIs now and just grabbing what they use.
So obviously for very large CLIs, if you were able to start, basically how would you start iteratively implementing something like this on a very large CLI already?
Yeah, so like individual commands at once. So to be honest, like I don't work on that large of a CLI. Like we have maybe 12 commands, but we do have a lot of dependent logic and a lot of. So that's where I started running into this like duplicating of business logic. So no, I mean just migrate individual commands one by one. You don't have you can use your existing scripts for all your other commands, but those that you do migrate, you have explicitly modeled state and actions. In fact, like I think the best way is to just copy and paste the entire like one entire command into an action, and then you declare the required state for that action, and that's it. That's the basic minimum migration. And then you look at that business logic, and you look at how you can split it up into intermediate actions that might be reused by other commands as well. And so I think that's the incremental migration story. I have to be honest, I haven't done it yet. Like this is something I've worked on as a proof of concept for eventually adopting. But I think CLIs at scale are going to need something like this.